So here we go, section 10.5, tangents, starting on page 735. Number 1, copy the figures shown and draw the common tangents. If no common tangent exists, state no common tangent. So for this circle, we can draw a line such that is tangent to this circle. We can draw a line such that it is tangent to the inner circle, but any tangent to the inner circle would not be tangent to the outer circle. See how it goes through the circle in 2 points here or 2 points there. And all of the tangents of the outer circle would not be tangent to the inner circle, so there are no common tangents. For number 3, determine whether FG is tangent to circle E. Justify your answer. So we have a theorem that states that a line is tangent to a circle if and only if it is perpendicular to the radius. So if we can somehow prove that this is a right angle, then we'll know that this line intersects the circle at exactly 1 point. So we have a right triangle, A, B, and where C is equal to 24 plus, since the radius here is 15, the radius there is 15. So the entire C length is 39. So we just want to check to see if A squared plus B squared is equal to C squared. If it is, then FG is tangent. If it is not, then it is not tangent because it would not be a right angle. So we have 15 squared plus 36 squared is equal to 39 squared. 15 squared is 225. 36 squared is 1,296. And 39 squared is 1,521. And my sum here is also equal to 1,521, which means that it is a right triangle, which means that FG is tangent to the circle. On number 5, assume that segments that appear to be tangent are tangent. Find x. So it looks as though this line is tangent to the circle, intersecting at 1 point. The point of tangency is point B. Therefore, it will be perpendicular to the radius at the point of tangency. We want to figure out what the radius is. So the radius here would also be x. The entire hypotenuse is x plus 18. And we use Pythagorean theorem, where this is my A, this is my B, and this is my C. So x squared plus 30 squared is equal to the quantity of x plus 18 squared. Now, remember from algebra, when you square a binomial, you have to write out x plus 18 twice. And you use distribution, or what I like to call FOIL, first, outer, inner, last. On the left, we would get x squared plus 900. So let's see what we get here. Our first times our first is x squared. Our outside times our outside is plus 18x. Our inside product is also 18x. And the product of our last terms would be 324. So from here, we're just going to do some simplifying. We have x squared on both sides, so let's cross that out. Let's combine our like terms here. And let's subtract 324 from both sides. So we get 576 is equal to 36x Divide both sides by 36, and x is equal to 16. Number 7. The landscape architect is paving the 2 walking paths that are tangent to 2 approximately circular ponds as shown. The lengths given are in feet. Find the values of x and y. Alright, so there are 2 parts to this. First, we're going to use our tangents for this circle and solve for x, then substitute x in, and then use our tangents to this circle. So we have a theorem that states that if 2 segments from the same exterior point are tangent to the same circle, intersecting the circle at exactly 1 point, then they are equal in length. So this point is equidistant from these 2 points of tangency. So the first thing that we want to do is set x plus 250, and we set that equal to 4x minus 500. So solving for x, subtract x from both sides, add 500, and divide by 3. And now that I know what x is, I can do my next part here. So now I have this length from here all the way to there is equal to this length from here all the way to there. So I can set those 2 equal. So I'm going to set x plus 25, where x is 250, plus, so this entire length would be x plus 25 plus x plus 250. So I have 250 plus 25 plus 250 plus 250. Is equal to, on the other side, this would be y plus 4x minus 500. Once again, x is equal to 250, so we can substitute that in here. So let's simplify. On the left side, we would have 250 and 250, that's 500 and 250, 750, 775 is equal to y. 4 times 250 would be 1,000. Minus 500 gives me 500. So subtract 500 from both sides, and y is equal to 275. So we solved for x first, we substituted that back in, and we solved for y. Feet. Number 9, copy each figure and draw the common tangents. If no common tangents exist, state no common tangent. So we would have one tangent right there. So we're assuming that these circles are intersecting at exactly 1 point, that the circles in fact are tangent. So that's a one common interior tangent. And then we would have 2 common exterior tangents, one there and one there. intersecting this circle in one point as well as this circle. 1 point here, 1 point there. I might have given too much detail here. It just says in the directions, draw the common tangents. So all you have to do is draw them. So that's what we'll do on number 11. So we'd have a common interior tangent here. Another common interior tangent there. A common exterior tangent here. And one on this side. Alright, see if I can do better than that. Okay, so 4 common tangents. Number 13. Determine whether each segment XY is tangent to the given circle. Justify your answer. Okay, so this was a lot like, what problem was it? Number 3. So in order for the line going through XY to be tangent, to touch the circle at exactly 1 point, then it needs to be perpendicular to the radius at the point of tangency. So we would apply Pythagorean theorem. If a squared plus b squared is equal to c squared, and that means that we have a right triangle, which means that xy is a tangent line. If it's not equal, then that means that this is some other angle other than 90 degrees, and therefore is not tangent. So, square each of these, we get 49, 576, and 625. And our sum here is also equal to 625. Therefore, yes, xy is tangent. Same idea with number 15. So this entire length is going to be 8. And we want to check for this angle right here. So this would be A, this would be B, this would be C. So is 5 squared plus 8 squared equal to 8 squared? I don't think so. This is 25, this is 64, this is 64. And obviously 89 is not equal to 64, so no, this line is not tangent because this is not a right angle. Find x. Assume that segments that appear to be tangent are tangent, round to the nearest tenth if necessary. And we have to use Pythagorean theorem again. So, assuming that this line is tangent, and that makes this a right angle, which means that a squared plus b squared will be equal to c squared. So we have 576 plus 100, which gives me 676. So let's take the square root of both sides, and x is 26. And we'll pick up from there on the next clip.